Welcome back to my podcast on the future of business and technology. I'm Bernard Ma, your host. In today's episode, I'm joined by Dr. Tom Marshburn, legendary astronaut, physician, and now space industry leader, to talk about life in orbit, the rise of commercial space flight and AI, and what it takes to lead, explore, and innovate at the edge of human possibility. Welcome, Tom.
Hello, Bernard. So good to hear from you.
Absolutely. Where are you joining us from today?
I'm in Houston, Texas right now, but I like to stay close to the Johnson Space Center. Our office is just across the street from there.
You've had one of the most unique careers: doctor, astronaut, and now space company executive. When did you first know you wanted to go to space?
I knew that space, in some ways, terrified me, but also vastly interested me when I was little. But then when I turned 13 years old, I read a book about the saving of the Apollo 13 astronauts. It was just a very detailed engineering description of what it took to save those astronauts. And that changed my life. I read it twice in one weekend, and I knew that I wanted to work for NASA one day. So that turned my course toward science and engineering in high school and then in college. And I got a graduate degree in engineering, but then fell in love with medicine too. I felt like that was where my path really lay. So had the privilege of being able to combine all those interests as an emergency physician, NASA flight surgeon, and then astronaut.
Amazing. And you've flown on three different spacecraft: the shuttle, the Soyuz, and the
Mm-hmm.
SpaceX Crew Dragon. What was the most surprising difference between them?
Well, the biggest is the difference between solid rocket boosters and liquid propellant. So the shuttle has its two main solids on the side, either side, and that takes you up to about 200,000 feet, and then they pop off. Those solids are quite violent in all degrees of freedom. You could read a gauge, but you couldn't write anything down. Certainly, I was on the mid deck, so I didn't have a window seat, but it was loud. Just the whole structure. Just rattling around you everywhere. I wouldn't be able to hear much more than just barely the comms from the launch control center and my crewmates. But once those pop off, it's just smooth sailing. Those liquid propellants just push you forward. It's almost like the hand of God pushing you up and accelerating you very smoothly. But then you start to take your breath in sips, and your arms and legs get sucked up under or behind you, and so it becomes a physical challenge of sorts, but it's lovely because you know where you're going. The thing that's similar with all of them is when you hit engine cutoff, all the noise, all the sound, all the hyper G just suddenly goes away, and suddenly you're weightless. And that's a wonderful moment.
Yeah, I can imagine. You spent 337 days in space. What were your most memorable moments?
The the first thing that comes to mind, of course, there is the view of the Earth from space. Spacewalks are the nucleus of all my fondest memories and my greatest not only aspirations but also the difficulty and challenges of working in space. But some of the best moments are looking at the Earth from space with someone else. So astronaut Chris Hadfield and I flew together, and our discussions about what we're seeing and sharing that with another human being is just unforgettable. And I've had a chance to do that, and I've made it a point to do that on every space flight. The schedule is quite punishing, so you might be surprised to know there's very few opportunities to do such a thing, especially two people at once, often on a weekend, probably no more than 45 minutes at a time.
Yeah, I had Chris on my podcast, and I was recently speaking to the British astronaut Tim Peake,
Mm-hmm.
and he was saying that the one thing people don't understand is how busy you are up there.
You are.
So we're now talking about the space economy. Where do
Mm-hmm.
you see the greatest opportunities that come from space?
Well, pretty much what we're talking about. There's several levels I would have to mention, really. First of all, there is the business of manufacturing drugs, chemotherapy agents, for instance, 3D print organs, these are things that can have a huge difference in not only our ability to take care of people on Earth, but our understanding of our own bodies so that we can better take care of people on Earth. When we're talking about materials, even though I'm a physician, I think of the biopharma side of things, but importantly, the semiconductor industry, if you can grow a nearly perfect crystal or a perfect crystal, which you can in zero G, which you can't do on the ground because of sedimentation and buoyancy effects, et cetera, then what that can do for communications and for computing in particular. I know you have a huge interest in AI, what you could do for that. Those are all things that are hugely promising for us all. But I would take also a bigger step back from that and what it does to the technical foundation of a country, for sure, and what it does for the education system. I've never seen people more motivated to work hard on these incredibly difficult disciplines than when they are motivated by either participating in a spaceflight program or becoming an astronaut and going themselves. I probably trained with or studied with 300 people over my lifetime. We all wanted to fly in space. They might have changed their mind later on or applied and didn't get in, but still here they have this wonderful degree with a high motivation and just adds to the technical capability of the human population. I love that aspect as well.
Yeah, amazing. You touched on medicine. So as
Mhm.
both a physician and an astronaut, how do you see space reshaping our understanding of medicine and healthcare here on Earth?
Well, yeah, if we step back from the purely academic or let's say scientific rationale for doing these experiments in space, which is profound and significant. We look at how healthcare is delivered in space. For instance, even though I'm a physician, I'm not an ultrasound technician by any means, but I was trained for 1 hour, 6 months before flight to perform ultrasound exams in space under the tutelage or the direction of an expert on the ground. We were able to produce ultrasound images, cardiac ultrasounds, echocardiograms, and other views of our internal anatomy as high a quality as the expert said, as a technician would on the ground, because we really perfected the technique for transmitting their information to us real time, so we could grab these images. And that kind of is the idea behind being able to provide medical care to a small remote team, which obviously translates to not only people that live in rural areas or countries that don't have adequate health care throughout their nation. It also applies in the US in an inner city when they can't, there's an 8 hour wait, before you can get into the emergency room sometimes. And to be able to do a real quick, rapid study on that person to say, oh, wow, you are an emergency. We need to get you in right away. That's all very important. The challenge is to bring healthcare to a small group of people using very low power, very low weight, very simple devices. Simple is important because you don't need a lot of training in order to operate them. And that's a big part of it. But also get just that data you need to be able to make a decision. These are all things that are absolutely essential in providing healthcare in rural areas and expand healthcare. Regarding the training, it's important too, because while a certified ultrasound technician, for instance, or certified anything in healthcare is absolutely important, we can probably provide a lot more healthcare to people without having to go through, um, the bureaucracy of making sure we have all the people and all the boxes checked, all the people involved that typically are in standard care. So I love the efficiency, the low cost, the rapidity with which we can deliver healthcare in space. And I think that applies to healthcare on the ground.
Yeah, that would be nice if we can transfer some of those learnings across.
Yeah.
You're now an executive at Sierra Space.
Mhm.
Maybe you can tell us a little bit more about what they do and
Yeah.
where they want to take it.
Yeah, sure. So Sierra Space is a space tech company. It's a leading prime in many areas of the spaceflight industry. We have three sectors. Number one is our Department of Defense. And so we are supporting the DoD and the nation in developing the tools we need for not just our nation's protection, but for planetary safety when it comes to rogue players around the world. But another major sector, and something we're intending to realize this year, is the flight of our Dream Chaser space plane, orbiting space plane. It's an ability to bring cargo to the ISS, eventually bring people up into space. But if you look at a picture of it, it's a winged lifting body. And so for me, it does me a lot of good to harken back a little bit to the shuttle days, but that's exactly what it's able to do, is have a very low stress entry into the upper atmosphere, much fewer G's coming in than say in a capsule coming in. There's no parachute opening snap, which there is in a capsule, and then you have a light touchdown on a runway rather than impacting the ground or the water under a parachute. And so not only is a gentle entry, you can deliver payloads to any metropolitan area in the world, really. Wherever you can land a 737, you can land the Dream Chaser. Highly reusable with the tiles, more advanced than what we had on the shuttle. So we're able to at least 15 flights per vehicle, probably many more than that. And then ultimately having a fleet of these to deliver people cheaply, but especially payloads and fragile payloads to and from Earth. It also shows some promise as a space ambulance. If you have an ill or injured crew member, you can bring them back safely to a metropolitan area right away if you need to from space. So there's a lot of interest in that. The last sector that we work on and that I'm part of is our habitats. That is our space stations and modules that we can build to fly in space. We've been working on the expandable habitat. Perhaps you've seen pictures and videos of that. We've actually put out a lot of videos of our testing of these. And for me, that's one of the most exciting aspects of the company, because you can, in any size fairing that you launch on a rocket, you're not limited by that size of your final module. That module can then expand with our technology. It can expand to 5 times that size. So you end up with an enormous, really enormous amount of real estate in space. And that, as an astronaut, I would love to have had that much space to live and work in, to build inside of, to reconfigure inside of, to allow not just laboratories, certainly not just laboratories within modules that are the size of the space shuttle, but huge sizes, do tech demonstrations, entertainment, etc. So that the wealth of possibilities with that, I find very exciting.
And where are you in terms of development with the spacecraft and the habitat?
So the Dream Chaser is in its final stages of preparation now at the Cape. We intend to be ready to launch this year, towards the end of this year, in the fourth quarter. Aeroshell has been placed back on. The inside is largely completed. It looks almost exactly like it's going to look like on launch. It's got some more testing to do and some certifications to undergo before it's ready to go. So that's right on the verge of flying. The habitats themselves are still well on their ways towards certification, burst tests, all those safety tests that NASA requires, which you can understand. We want to be able to demonstrate, and we've so far been very successful in demonstrating that. One aspect of those habitats is they have to protect from micrometeoroid debris as well. So we've been doing hypervelocity impact testing at White Sands and been able to show that you can, it's just as good, if not better, than aluminum structures. So all of that testing is still ongoing before we can start launching those habitats.
And then those habitats, how do you envisage them being used?
So you come up in a fairing and then expand them. So you have a lot of space there with a central metallic core that contains the life support systems, et cetera, that you need. The Dream Chaser can bring up the relatively lightweight, small structures you need to build out from that central core, or not, or leave the space open for whatever kind of demonstrations, free flying robots, or whatever NASA wants to demonstrate in a big, huge open space, in a short sleeve environment. So, and again, from an astronaut standpoint, I love that idea. We certainly love the science that we do in space. We love the maintenance work. We love to use our hands, our eyes, and our brains in a creative way. And this allows astronauts to build and reconfigure the internal volume of their spacecraft and not be constrained to smaller volumes with metal walls that you can't change. I would say the biggest problem in space for long duration, we know that there's atrophy and radiation and those things, but from a psychological standpoint, one of the biggest problems is waking up every day and seeing exactly the same thing every single day on the inside before you look out a window. So this allows us to get around that, to build the world you want to have when, for instance, you're on your way to Mars and you're going to be living inside this for years. So I see that as a huge advancement.
And do you see uh, those habitats or similar habitats being used on the lunar landscape too in the future?
Oh yeah. Eventually, we'd get to that, and on the Earth, if you can stop a 25,000 mile an hour object hitting the side of your uh, habitat, you can certainly, that has applications of being able to deliver safe healthcare systems, or into war-torn zones around the world, be able to deliver that right away and set up a habitat there. But certainly on the moon and on Mars as well. Small volume, get it on the surface, expand it, and now you've got a lot to work with. And
Yeah.
it's relatively safe compared to other structures.
Yeah, I can see there's so many applications of
Oh yeah,
that.
yeah,
Fascinating.
yeah.
Space is increasingly commercial and
Mm-hmm.
AI powered. How do you see the role of automation and AI evolving in future missions?
That is fundamentally integrated into our designs and then into our concepts. When we talk about healthcare in space and biopharma, we're in the initial stages. Before we get to the large scale manufacturing, we're going to be looking for the right answers, the right paths to go down. That opens a business case. And one way to do that is have huge volumes of small specimens going into space, and a way of understanding what the results are from each of those. Not to mention, say you have stem cells, which we can grow organoids, so we can create the organ that you want to study in space, which, by the way, actually can replace and is allowed by the FDA to replace the animal models that we use on the ground, and to repeat that thousands of times with different chemotherapeutic agents. And you can learn about how toxic is this drug, what's the benefit to it for that, even that person's specific cancer, if you fly up many people's individual small little samples of their cancer into space. AI is going to be essential with all the inputs that are needed to make sure they understand their environment, the output that we get from that. And that's just in the biopharma. I think we're looking at large scale, very complex systems such as this, and AI is going to be essential. When it comes to healthcare, also, as you can imagine, keeping your AI um, assistant in space, always informed by the specialists on the ground, and helped if you have a physician on board. But still, when we go to Mars, there's not going to be any real time communication. There's going to be a delay of 45 minutes, and we'll need that AI system with us.
Yeah, fascinating. Do you see a role of humanoid robots or autonomous agents when it comes to space habitats and lunar bases in the future?
Certainly. That's going to be essential as well. It's dangerous and difficult to get a human in a suit. For instance, we have a ways to go. I don't think we'll ever be able to replace the human, as we often say with AI. The ability to, let's say, let's look at Mars as an example, where we've had robots kind of making the big decisions of, yes, we can land in this space. This looks like an interesting area. And over the years, and it can take months for a geologist to make a decision for the robot to go there, um, then they can get a sample and detect something. But if you put the geologist on the surface, only the geologist, as far as I know, can say, oh, what is this over here? This is interesting. Let me go look at that too. And very quickly be able to do that. And that's sort of an analogy of how we're going to have the marriage of the robotics and the human in space to get so much more done than we currently do.
So, what are the kind of tasks that you think you should pass on to a robot, and what are the tasks that should remain human?
When it comes to the decision point, I think the human needs to be informed, but the human is the one most likely to be able to detect, of course, your extreme hallucinations that AI can provide, but also to understand some details that AI, which is just drawing, say just, but is drawing from what's available on the web to learn. But to be able to say, oh, that is true or not true. I personally, and I've done this with space medicine, look things up using AI, and it's wonderful. It does a literature search for me, but the conclusions it draws from the literature tells me that an expert has not looked at this, because there's more accurate conclusions one can draw from the human. I don't need the research team necessarily to look stuff up for me, but it's still need to be there to make the conclusions.
Yeah, I couldn't agree more. I'd love to know a bit more about how Sierra Space is using cutting edge technology like AI, advanced materials, or biotech to shape the future of human space flight. You touched on some of them already. What
Mm-hmm.
are some of the most exciting technologies you're using?
Well, a lot of them have to do with our spacecraft. I'm involved, intricately involved, and intimately involved in some of the design features of the habitats and of the Dream Chaser itself. So, um, the greatest impact in my mind is opening access of space to more humans than, say, typically your government agency, NASA, would have allowed. The technologies that we're searching for, and we're working with universities around the world to do this, are technologies that would, say, allow someone with a chronic disease that never would have been selected as an astronaut, say they have diabetes, to live and work long duration in space, bringing the technology with them that's needed for little extra monitoring, for instance, to detect if a problem starts to occur in their physiology. So from that standpoint, it's going to open up the doors for sure for more people to fly in space. But even those with, say, blind individuals, people that have difficulty with hearing, that actually opens doors for possibilities that we never would have considered. I think it's very helpful to have, say, a non-visual alarm system. If you're in a smoke-filled cabin, a big cabin fire, your visual indications don't help you much. The audio indications would do better. As a matter of fact, I think a person without eyesight could navigate around through a space station just as well, if not better, than someone with eyesight, because
Mm.
they're not distracted by up, down, left, right, which can be quite confusing. But the sounds, the nuanced sounds of a spaceship, which we detect after a few months, is something that individual would detect right away. So we're able to unleash the superpower of those who have a certain sense that has been reduced, unleash that capability to make the spacecraft safer for us, and eventually for buildings and habitations on Earth as well. So it's basically going to unleash the potential of all people to get up. And when you work hard to get them in space, I think that's very exciting.
Yeah, very exciting. What mindset traits or skills do you think will define the next generation of astronauts, or indeed leaders more broadly?
Mm-hmm. An ability to think across various disciplines, the work it takes and the focus it takes to get good at one thing is an important skill to have, and that's built up over a lifetime. But also a curiosity that takes that analytic skill and broadens it across many different fields. The other is we're going to be working in teams. Very rarely, if ever, do we want just one person in space. So emotional intelligence and the ability to work with a team with very highly qualified individuals or colleagues that are with you in space, and to work with them, just them, for potentially years, 3.5 years on a Mars trip. Those are things that I think will be very important. We learned a lot about that, especially on my last flight, and I've learned a lot about that on my through my career as NASA, the military and NASA has gotten much better at figuring out how important that is, and so
Mm.
that's been a fascinating aspect as well.
So, what were the key learning points you've taken away from that?
Well, several things. The recognition of team members all have something to contribute. Every individual is good at something, but no individual is good at everything.
Mm.
So it requires an injection of a certain amount of humility in the team that you're working with. And I was commander commander of the space station on Expedition 67. Highly qualified, really good crew to work with. The ability to take their inputs and let them take the lead on a certain event. We had a few false alarms, fortunately, but a few emergencies that occurred up there, and allowing them to shine. It was, for me, a very important aspect of it. We also went in with a lot of mutual trust. We started our mission with close one-on-one conversations with each other and with just us as a team, no supervision, to say what we all thought we needed to work on to work better as a team. And we exercised that throughout the flight. So by the time we finished the flight, we were able to tell NASA, hey, everybody was just great and great at everything, because it was true, because we had deliberately worked on that from before the mission. I mentioned humility as it sounds like a virtue. Oh, isn't that nice? But really, it's a realistic view of the world and our interactions with people. Um, those who can't take inputs from others and assess them are people that just don't have a realistic view. I think, because none of us. This is way too complex, way too dangerous for any one person to figure out and do. We've all got to work together as a team.
Yeah, I love that. I love the fact that you use two words that I use all the time. I've
Right?
written books on the most important skills we will need in the future, and I actually summarize this in a number of articles, saying actually it comes down to curiosity and humility. So
Hmm.
I love the fact that you use those two
Yeah.
words as well.
And don't want to ignore the very important skills, though, and that's tenacity is one of the biggest ones as
Mhm.
well. We all love to work, and we have to remain very patient and tenacious to reach these good big goals.
Absolutely. What advice would you give young people today that want to follow in your footsteps
Hmm.
as astronauts, innovators, or explorers?
I think the practical aspect of it would be look at those people who have done what you wanted, that you want to do. I studied astronauts' bios when I was younger. Somebody has done something that will speak to you. You will be able to go off and recreate what that person did in a better or much more personal and different way that is actually wonderful. But if you can find those things that speak to you, you will start to do what you love, and that is essential. All the astronauts will tell you that. Do what you love, because then you'll be good at it, and that's very true. But also make sure that you say yes often to challenges. There's not a single person on this earth, especially with astronauts, that have not failed multiple times along their way to reaching their goal. As a matter of fact, the failure, I would say, is essential to our success, because, and NASA knows this, by the way, they know that somebody who has failed and recovered and learned is much more valuable to them than someone who never seemed to experience failure ever. Because in space, you probably will experience that. Hardware just doesn't cooperate sometimes. Events occur that no one could possibly predict, especially in space and zero G. So um, we have to be resilient and able to take all that in. So say yes and accept things. If you don't feel like you're much of a leader or you're shy, take a leading position. Try to run something and learn from that. So those two things are I think really essential to getting what you want.
Yeah, I love that advice. If you look into the future, then what are your biggest fears or biggest hopes for our future? I mean, you've got this amazing perspective of having spent
Hmm.
almost an entire year looking down
Hmm.
onto our planet. What are your biggest fears and hopes?
So, a lot of astronauts talk about the fragility of the Earth as viewed from space, and while that's true, I think I would have to caveat it. The fragility of human presence on the Earth from space. So, do I fear for our future as human beings? No, but I the love the life on the Earth more than I ever thought I would before. The Earth is yes, it is the embryonic stage of life, but it is just a very, very thin, hardly even a film. It's just a dusting on the outside of this huge planet that we call Earth. And the atmosphere is, while it's as deep as the ocean, it's still just an incredibly thin um, wisp of gas above us, and we're at the bottom of this wisp. So we and the conditions that sustain life seem very fragile. The Earth looks robust. As a matter of fact, the Earth seems like it could just shrug us off in a second, and space and the Earth wouldn't notice it. So I find that means that human beings are incredibly precious, probably in the entire universe, but certainly within our solar system, as it certainly seems to be. So I really hope with our maturation as a species that we get to where we not only take care of each other, we take care of the planet, but also continue to reach out. One of these days, we'll need to go to another planet. I think the human intuition is such that, and our capabilities are such that we will accomplish that one day. It might be a long time from now. We might have to accelerate if we find an asteroid heading our way that we can't avoid. But we've got some time, and it's good to figure all those things out now.
Amazing. Thank you so much. I could carry on forever. So many really valuable insights that you shared with us today. Anyone who ever wants to re-watch or re-listen to this, you can simply watch this on my YouTube channel or go to any podcast platform where you can listen to this and hundreds of other conversations on the future of business and technology. Thank you very much.
Thank you.